Hello everyone, in this video we'll see how to create lists in Python. So in order to create a list you have to use square brackets, okay? And if you write any number of values, separating each value with a comma sign, then you have a list. So it is quite simple to create. So here we have 3 memory blocks created, okay? All 3 belong to this variable L, and each memory block has an index value associated with it. So this element 10 has index 0, 20 has index 1, and this 30 has index 2. And this index can be used to access the values of the list, okay? So we'll see to it. So what exactly is a list? So you can say list is a collection of values, okay? And these values can be of any type. So in this example I have created a list of integers, you can say, but you can create a list. For example, L is equal to, I can write a name of a person, okay? So here I have created another list, and here I am storing string values, okay? So you can also have a list of strings. Similarly, you can have list of float type of values, okay, like this. You can have combination of values inside the list, like you have few integer values, you have some float type of values, you can have strings, you can even have lists inside a list, for example this, okay? So technically you can simply understand this in a way that a list can contain anything inside it, okay? Anything means anything. So to understand this type of list properly, you have to remember one thing, that what is the organization of these elements inside the memory. So here this element 1 has index 0, this is 1, this is 2, this is 3, 4, and this is of course 5, and this list, this inner list, okay, is stored at index 6 here, okay? You cannot say that this value 10 is at index 6 and 20 is at index 7. No, at index 6 inside this list you have this complete list, okay, containing elements 10 and 20. So this is how lists are organized inside the memory. So once you create a list, for example, let me recreate it with elements 10, 20 and 30. How do you access these elements? For example, if you want to print the entire list, you can simply write the list variable name here and the entire list will be printed. Or you can use the index value which is associated with each element of the list. So how do you do it? You can simply print L square bracket 0 and it prints 10 because 10 is stored at index 0 in this list. Likewise, you can access any element by using the index value. You can also apply a loop on this list in order to access the values. So for example, if I have a list with these elements and I want to print them one by one, so I can apply a for loop here for I in range. Of course I have to use range here because I want indices, so I can simply write 3 here. Okay, why? Because the start value will be taken from 0 and this 3 is acting as a stop value, and stop value is not included again, so it will stop at 2. So 0, 1 and 2, these are the 3 values that are going to be generated by this range function, and these 3 values will be given to this variable I one by one. So inside this loop you can simply use print statement, and here you can write L I. Okay, so when I is 0 it will print L0, that is 10. When this loop comes back again, it will, this I variable will be 1, so it will print L1, that is 20, and next time it will print L2, that is 30, and then this loop will stop. So let's see its output. As you can see, it is showing us 10, 20 and 30. So what you are doing here is you are accessing the elements of a list one by one. Okay, so I hope this concept is clear to you. Now let us see how to create empty lists. Okay, so to create an empty list you have two options. The first option is to use empty square brackets and just press enter. So you have an empty list here. If you print L, you can see it is showing this empty square brackets here, which indicates that the list is currently empty. Now the second way of creating empty list is to use a function list. Okay, and since it's a function you have to use these brackets with it, and you write nothing inside. So when you press enter key and when you print L, you can see it has again generated an empty list. So these are the two ways of creating empty lists. Now once we create an empty list, how do we fill it with values? Okay, so in general understanding you might think it as, you can simply write a statement like L0 is equal to 100. Okay, logically if you think this should work, but in case of lists this assignment operator is not going to store new values inside the list. Now remember what I'm saying, you are inserting a new value in the list. Okay, so in order to insert new values you must use a dedicated function for it, and it happens in list only. With the other objects that we'll be seeing in the upcoming lectures, you will see that you can insert new values even like this, but that is not the case with lists. Okay, so you have to use dedicated function. So I am in the script mode here, and let's create an empty list first. So I use a function list with nothing inside the brackets. So this is an empty list and I want to fill it with values. So let's fill this list with 5 integer numbers. Okay, so for that I'm going to use a for loop, and I'm going to ask each value one by one to be entered from keyboard. Okay, so for I in range 5. Okay, so this loop is going to going to be executed 5 times, and the values generated here are 0, 1, 2, 3 and 4. So these are the values that I want, and these are the values that I can use as index values. But as what I said earlier, you cannot use index values to insert new values inside the list. Okay, so in order to make this program work, you have to use a dedicated function. So that dedicated function here is called as append, and append is an object specific function. Okay, so remember, object specific function always work with object. For example, L in this case. and before I append, let me store a value first in a variable n. So I want numbers in the list, so I am going to store one number at a time. So int input enter value. So whatever user enters in this variable n should be stored in the list. So for that purpose I have used this method called append. So the meaning of the word append is adding something at the end. Okay, remember the meaning of this append word. So whatever I specify inside these brackets, that value will be added or will be inserted at the end of the list. So that's what it is. So what do I have to write here? N. So whatever is entered in this variable n will be added to the list, and in fact will be added to the end of the list, and that's exactly what we want here. So that's it, our program is complete. Outside the loop you can print L to print all the elements in one go. Okay, so let's run this program and see if it works. So as you can see, it is asking me a value, let it be 10. So 10 is added to the list, okay, because of that append function. Then when I enter 20, 20 is added to the list, 30, 40 and 50. So as you can see, it has generated a list of 5 integer values, and all the values were entered one by one. Okay, so this is how you can create a list by specifying it as an empty list first, and then you can fill it with values by using a loop. So I hope it is clear to you. So the next thing I want to explain here is how do you access list elements here. Of course you already know that if you print L0 for example, it will print the element at 0th index. Okay, so this is one way of accessing elements. Another way of accessing elements is to use slicing. Now if you have understood slicing in my string video lectures, there should not be any problem understanding list slicing, because it has no difference whatsoever. The slicing is applied on the list in the same way it was applied on the strings, no change at all. So again, as far as the indexing is concerned, every list element has a positive index as well as a negative index. So this element 10 here is having index 0, 1, 2, 3 and 4. This is how it is going till this element 50, and from here the negative indexing starts. So this element 50, which is the last element of the list, will have the index -1, the negative index -1, and we go back in the order. So this 40 will have -2 index, 30 is -3, this is -4 and 10 is -5. So let's print L -5. So what value should we get? 10 again. So this proves that the list also has negative as well as positive indexing system. So if you know this, you can apply slicing on the list easily. So to apply list slicing, you can use again the same technique, use square brackets and write inside start, stop and step values. So if I write 0 as the start value, colon 4 as the stop value, and if I leave the step parameter, as you already know it is an optional parameter, so by default it is 1. So this slicing is going from index 0 to index 4, that is 4 is the stop value, so 4 is not going to be included in the output. So 0, 1, 2, 3, this is what I should be getting here in the output, and this is in fact the output. So slicing on list is completely same, guys. So I recommend you please watch the slicing videos in my previous lectures, and you can apply slicing on list in the same manner. Another thing I want to explain here is that I want you to know that a list is a mutable type object. Now what mutable type object actually means is that you can overwrite the same memory block with a different value. So for example, this list has 5 memory blocks. Okay, so if I want to modify the value of any memory block, so here I can use the index. Okay, so if I write, for example, L2 is equal to 999. So as you can see, it has worked, and when you print the list, the element which had index 2 is now 999. So the previous value which was stored at this index was 30. So we can say, since list is a mutable type, 30 was overwritten by this value 999. Okay, so there is no new memory block created here. As opposite to this, what we saw in case of strings and integers and of course floats, these are all immutable types. So when you assign a new value to a variable which is already holding a value, and if that variable is of immutable type, then a new memory will be created every time. Okay, so that I had already explained in my previous lectures, so I guess you already know it. Okay, so this is one property of list that you have to remember, that list is a mutable type. And what mutability means is no new memory is going to be created if any block of that type is changed, or it is actually overwritten in fact. Okay, so just remember that. Now at this point we already know that a list can contain lists. Okay, so for example, if I write L is equal to I am creating a list of integers, so 10, 20 and 30, and I am going to have another list inside this outer list. Okay, so this inner list is going to contain two numbers as 11 and 22. Okay, so this is the list that I am having right now. Now as I told earlier, if I ask you how many elements are there inside the list, or simply what is the number of elements inside the list, what will you say? The length of the string or the number of elements inside this list L is 4. It is not 5. So you have 10, 20, 30 and a list. So these are the 4 values that are stored inside the list. And of course this 10 has index 0, this has index 1, 30 has index 2, and this complete list has index 3. So what happens when you print L3? Okay, what should it print? So if you have understood the indexing system here, you can simply predict that it is going to print 11, 22 both. In fact, this entire list is printed. And why is it so? Because this list, this complete list is present at index 3. So every time you print L3, it is going to print, or it is going to access this inner list. But what if I want to access the individual elements of this inner list? So for example, I just want to access this 11, or I want to access this 22. So what do I write here to do it? So first thing is you have to reach to that memory block. So it is L3 in this case. So when we have come here, and when system finds that it is a list, then you can simply use another square bracket, and inside this second square bracket you can specify the index of the inner list. So I have written L31, and it is going to give me what value? 22, which is what I wanted. So how is it working? So when you have written L3, it reaches here, and at this point it reads this statement. Okay, so it has to fetch the value from index 1 from whatever it finds here. So it is a list in this case, so it is going to find the index at it is going to find the value at index 1 here, and then this is how this element 20 is being accessed. So I hope this is clear to you. Now you can also apply loops on this list in a way where you are not going to use indices in order to access elements. You can directly access the elements. Okay, this is the thing that we have already seen in case of strings as well. So that same thing we are going to apply here. So what do we write? First of all, we open a loop, for loop. So for I in, now I'm not going to write range here. Why? Because I don't want indices here. So I'm going to print each element on screen by using a loop without involving index values of any element. So what you are going to write here is, you can simply write the object L here, and that's it. Okay, same case is there with strings also. So what happens when you write L here is that this entire list L is placed here, and then each value one by one is given to the variable I. So nothing new here. So the first value of I is going to be what? It is going to be 10, and the second value is going to be 20, third is going to be 30, and this goes on. So when you print I here inside the loop, what should be the first value that's going to be printed? 10. Now again I'm saying students often write this statement like this. Now this is not going to work here, because if you write it like this, it will be interpreted as, you know, first time when I is 10, so it is interpreted as L10, and L10 is no index here. Okay, it makes no sense here. So just remember, when you are accessing elements directly like this, you have to simply write the variable in which the values are coming one by one. So there is no involvement of indexing here. So let's try and run this program. I'm going to run it, and as you can see here on the output screen, it prints all the elements one by one. So again, you have two options of accessing the elements. One is of course by indices, and second is this, that is directly accessing elements from the list, just like what we saw in case of strings. Now the next thing is, suppose you have a string value stored in a variable s. Okay, can we convert these can we convert this string into a list? Okay, that is the question here. So let me write a statement, and then you can predict the output. I'm going to write L is equal to, or let me take capital L here, it's not a compulsion though. So L is equal to, I'm going to typecast this with this function list. Okay, so list, I'm going to convert this string s into list, so I have to write s inside the bracket. So this is the indication that convert this s into a list and then give it to L. Now should this statement be working? Okay, that's a big question. So the answer is yes, it works successfully, no problem at all. But how does it work? It takes one by one each character from this string and then puts it inside the list. Okay, so when you print this list L, as per what we might have expected, we have each character separated from the string and stored as single element one by one inside this list. So now we have this list containing 6 characters, or you can say this list is containing 6 different values. So this is how you can convert a string into list. But if you want to achieve the reverse. Okay, is it possible? Let's see that also. So if you have a list, or in fact I already have a list in which I have stored these values. Now for some reasons, if I want to convert this list into a string, so can I do it? Let's try. So in which type I am going to convert it? str, which is string. And what am I converting here? L. So convert this L into string and give it to S. So it says it works, but when you print S, see what happens. So what it has done is it has taken this entire list inside the string. Okay, so you know, this square bracket, the opening of this square bracket, this single quotation mark, and the comma sign here, all the single quotation marks here, the closing square bracket. Okay, so every single thing is enclosed inside the single quotation mark. This is what it has done here. As you can see, when you print S like this, it has, you know, the quotation marks applied here, which is an indication that whatever you specified here, okay, is considered as a string. So this is not what we wanted. Okay, we wanted to recollect each character from this list and then store inside the string. So this is simply not possible directly, but you can achieve it by using a loop here. Okay, so let's do it. So suppose I have a list containing 3 different character values as R, A, J. Okay, and I want to convert it into a string as a collection of these characters. So the name of the person is Raj in this case. So I want this Raj to be stored in a string. So what do I have to do here? I have to use string concatenation here, where one string plus another string yields a third string. So that's the logic I'm going to use here, and for that purpose I'm going to apply a loop here. So for let me declare a variable first. So S is equal to empty string. Okay, and this in this empty string I'm going to send each character one by one. In fact, I should say, in this empty string I'm going to concatenate each character one by one. Okay, so for I in L, this will serve my purpose because I don't want indices here. The values, the direct values will do my job. So for I in L is what I have written here. So what is going to be the first value of I? It is R. So I have to concatenate this R in this string S. So what do you write for that? S is equal to whatever S is plus the incoming value of I. So the first time S is nothing, it's empty. So empty string plus the value of I, which is R. So empty string plus R is R, and then that R is stored back in S. So this is what I'm doing here, string concatenation. Similarly, when this loop goes back and comes inside, the next value of I is A. But by that time, the letter R has already been stored in the variable S. So what value is placed here? R. And what value is placed here? A. So it becomes RA, and RA is going to be stored in S. Similarly, next time, third time, this is RA and this is J. So this becomes RAJ. So every time the loop is executing, it is actually concatenating one character in the string S. So let's print this variable S and run the program and see if it works. It works fine, as you can see. So this is how you can convert a list into a string. Now one interesting thing about lists is that you can use list slicing to change the values inside the list. Okay, so how do you do it? Let's see. So I have created a list this with 4 elements inside it, and now what I'm going to write is L2 is equal to L0:3, for example. Okay, so what it is going to store in L2? 10, 20 and 30. So let's print L2, and as we expected, 10, 20, 30 are stored in this variable L2. Fine. Now if you write a statement like this, L is equal to, or L square bracket, I'm going to use slicing here, 0:3 is equal to nothing, empty square brackets. Okay, so what should it do? So here I am using slicing first of all. So I am talking about the start value 0 and stop value 3, that is 0, 1 and 2. So we have 10, 20, 30 stored at these 0, 1, 2 indices. So what this statement is going to do is, when you print L, you can see it shows only 40 now. So when you write empty brackets with slicing on the list variable, all the values that are coming in this range, in this slicing, are going to be replaced by whatever you specify here. So that is what it is going to do. So this is the slice range 10, 20, 30. So 10, 20, 30, all values are going to be replaced by an empty list. So it means that these values are going to be deleted from the list. So this is one way of deleting elements from the list. And you can do the same thing by writing the code like this: L0:3 is equal to single quotation marks. Okay, so let's see what L is now. Again 40. So either you write an empty bracket here, or you write empty square, either you write an empty square brackets here, or you write an empty string here. In both the cases, it is going to delete all the elements that are coming in this slice range. Now remember, this works only with slicing. So what if I want to, suppose if I recreate the list and I want to get rid of this value 10, I want to delete the value 10 here, and the easiest way is to use slicing again. So I can use L square bracket. Now remember, I must use slicing here. Okay, directly it won't work. So I am writing 0:1, okay, is equal to empty square bracket. Now should this work? So how many indices are placed here? Only 1, because 1 is the stop value. So it is stopping at 0, starting at 0. So only L0 is what we are talking about here. So when you press enter and when you see L, you can see the value 10 is gone from the list. So this is how you can delete one element, 2 elements, 3 elements, or whatever number of elements you want to delete. So this is one technique of removing elements from the list. Of course, we have dedicated functions for removing list items, so that we'll be seeing later on. You can also use the same logic in order to replace multiple values. Okay, so if I write L0:3, okay, so about how many elements I'm talking? 0, 1 and 2. So I'm talking about elements placed at index 0, 1 and 2. So we have 0, 1 and 2 here in this list. So what do I want to do with this is, I want to replace these 3 values with 1, 1, 2, 2 and 3, 3, for example. So when you print L, as you can see here, the 3 values here in the original list are overwritten by these three new values. So this slicing with list can also be used for replacing values. Okay, so this is one thing that you have to remember. And what happens when you write the same statement for more than the values that are specified in the slicing? So for example, here I am talking about 3 values and here I am supplying 4 values or maybe 5 values. Okay, so what should it do? Okay, so as I said earlier, that you have to remember that whatever you are writing here is going to overwrite whatever is coming in this slice range. So for example, in this case we have 3 elements coming in this slice range. So simply these 3 elements or this range that I am showing right now, this much area of the list will be replaced by this. Okay, this is the simplest way you can understand this. So when you press enter key, it works, and when you print the list, as you can see, the area where I had 10, 20, 30 earlier is now overwritten by this value. Okay, this list in fact. So this is how you can use string slicing to have more than one values inside the existing list. Now another thing I'm going to explain here is list concatenation. So suppose you have a list L1 and you have a list L2 which has elements for example 1 1 2 2 3 3 and 4 4. Okay, and you want to join these lists. Okay, you want to merge one list into another. If you want to perform these type of operations, you can do it easily by using plus sign. Okay, so let me create a third variable L3 which is going to store first list, all elements of first list and all elements of second list. So what do you write for achieving that? You write L1 plus L2. Simple. So when you print L3, as you can see, the second list is merged with first list. And if you had written L3 is equal to L2 plus L1, and then when you print L3, as you can see here, this list 2 is coming first. So the first list is merged with the second list, you can say. So the order in which you are writing list variables here is very, very important. So this is how you concatenate lists. So another thing that we should discuss here, which happens with mutable objects, is that when you create a list, for example 10, 20 and 30, and you assign this list to another list variable L2. So for example L2 is equal to L1. So how many lists do I have here? I have 2 lists. First is L1, second is L2, and of course they both are same. If you check the memory address of these 2 different lists, let me do it here. ID of L1, it is this, and ID of L2. So as you can see, it is same. Now we have seen the same type of thing in case of immutable objects also, when where we had 2 integer variables, and in that video I explained that whenever you assign same value to 2 different variables, no new memory is going to be created. But what happens in immutable types is, as soon as you change value or as soon as you reassign a different value to any of those 2 variables, then a new memory block is going to be created. Okay, but this is not the case with mutable objects like lists. So let me show it to you with the help of example. If I make changes here in L1, any of the elements of L1, okay, not L1. So if I do it, L1 of 0 is equal to 999, okay, and then when you print L1, of course the 0th index, the element at 0th index is overwritten by 999. So after this, when you print L2, surprisingly the list 2 has also changed, okay. This was not the case with immutable types, and this is exactly what immutability means. That says that whenever you assign a new value to any immutable type, a new memory is going to be created. But in case of mutable types, the assignment happens at the same memory location. So what's happening here is, when a single memory block is being changed, whether it is via L1 or via L2, this operation is happening at the same memory location where L1 and L2 both are pointing. So if you make changes in L1, it is going to reflect in L2 as well, or if you make changes in L2, it is going to be reflected in L1 as well. So just remember this property of lists. So that's it for this video. I hope all the things I have explained here are clear to you, and do practice these things on your own to have better understanding of whatever we have discussed in this lecture. Also, in the next video we'll be discussing some inbuilt functions that can be applied on lists to manipulate list items, okay. So thank you so much for watching. If you have liked the content, please comment, like and share, and do subscribe to my channel. Thank you.